So excited for this lesson. We are going to be factoring or beginning to factor quadratic expressions, some of my favorites. We're going to begin today by using the greatest common factor. So first of all, I want you to do this warm-up, so pause the video for a little bit. Use the distributive property or the FOIL method on some of these in order to find your answer, and then come back and check to see that you've got them correct. So you factor or multiply the 3 across the parentheses, 3x minus 6. Again, x squared minus 9x. Here we're going to use the FOIL method, the first, the outside, the inside, and last. And 9x plus 5x is negative 4x. And then finally, x to the fourth minus 4x to the third plus 5x squared. So we multiply the x squared by every term. Key concepts for this lesson. Factoring is simply rewriting an expression as the product of its factors, or we think of factoring as undistributing. It's the opposite of distributing. Greatest common factor, the largest quantity that is a factor of all the integers or polynomials involved. So let's get busy. First of all, we're going to find the greatest common factor of each of these numbers. We'll break down 12 as 2 times 2 times 3. You can use your factor tree to factor also 8, 2 times 2 times 2. Notice that each of these have two 2's in them. So the greatest common factor is 2 times 2, or 4. So 4 is the largest factor of both 12 and 8. Let's look at 7 and 20. Well, 7 breaks down as 1 times 7. 20 is 2 times 2 times 5. So we prime factorization. Nothing is the same. So there's no common prime factors. The greatest common factor for these two numbers is 1. Now let's find the greatest common factor. We've got some variables here. X to the third can be written as x times x times x. And I'm not going to say this x 7 times, but as you notice, the common is 3 x's between the two of them. So the greatest common factor is x to the third. Now we have 6x to the fifth and 4x to the third, so let's factor these two. 6 is 2 times 3 with 5 x's, and 4 is 2 times 2 with 3 x's. So we've got 2 in common and x to the third. So 2x to the third is our factor, our greatest common factor for these two terms. All right, now let's factor A, B, and C here. What is the greatest common factor of 15 and 100? Why, it is 5. If we pull out a 5, that leaves 15 divided by 5 is 3. That leaves an x squared. We can't pull out any x's because this term has no x's. 100 divided by 5 is 20. And that should be a positive 20. Looking at 8 and 4, the greatest common factor is 4. And an m is common between the two of them. That leaves 2m plus 1. The greatest common factor is 3 and an x. That was going to leave an x, and 6x divided by 3x is 2. Now let's factor out the greatest common factor in each of these polynomials. So what is the greatest common factor between 6 and 9 and 12? Why, it's a 3, right? 3 is the largest number that goes into all of them. Each of these terms has an x, so we can pull out a 3x out of every one of these. 6x to the third divided by 3x leaves 2x squared. A negative 9x squared divided by 3x is 3x. And 12x divided by 3x leaves 4. So if we pull out that 3x, that leaves 2x squared minus 3x plus 4. So see how we decided what we're pulling out and what stays inside the parentheses. Okay, let's look at another one. What's the largest number that comes out of every one of these coefficients? Y, 7, of course. And that each one has an x and a y, so let's pull out a 7xy. This term divided by 7xy, 14 divided by 7 is 2. X to the third divided by x leaves x squared, and we've pulled out the y. If we pull out a 7xy here, all it leaves is an x. Pull out a 7xy, we've got a -1. That leaves 2x squared plus x minus 1. Excellent. Okay, let's take this up a notch. Now we're going to factor out the greatest common factors of this polynomial. What do you notice that's alike? Why, that x plus 2, right? If we pull out the x plus 2, that leaves 6 minus y in the other parentheses. Isn't that awesome? How beautiful that works. What's common here? Y plus 1, but there's nothing here. What's understood to be here? Y1, of course. So we've got y plus 1 times xy minus 1. Very good. You're ready to begin working on the assignment.